for giving us a chance to present us by ourselves. So, a few words to MERSEN. We, as MERSEN, are a global company, and we are really dedicated to passive electronics, means also safety in the case of the battery world. And it is a pleasure really to give us to have the chance today to present our solution to the not only to the battery, also to the battery energy storage solutions. So to give you an overview about what we can do, as mentioned already, safety, fuses, cooling is also related to safety, and as well connections. A proper connection is really also a key component to be efficient at the end of the day, but also to ensure the proper connections and to keep also manufacturing footprints here in Switzerland. So we will switch to the agenda. First of all, I will present you the speakers. Then we go step by step into the laminated bus bars, where we can grant the interconnection, but also the monitoring inside of these laminated bus bars. Afterwards, we switch to the high-speed DC fuses, which is a big topic, especially in the energy we actually store and distribute then through the batteries. This is a high topic. And of course, all of this is also linked to cooling. And what we have in mind also to have a question and answer session at the end. But don't hesitate to share your questions during the presentation in the chat, and we will try to answer you directly in the question and answer session. So who we are in front of you. So my name is Stefan Probst. I'm located here in Bern. I'm the general manager for a distribution company for whole Switzerland. We cover all the markets and all the products here for Switzerland, for the domestic market of the MERSEN portfolio. What we do, I will show you later, beside of these 4 products. Then we have really keynote speakers, and I'm proud of have such a high power, high experienced team around me. It will go to Damien Lacoste, who is the product manager, the global product manager for bus bars. He is located in Saint-Bonnet-la-Mure. This is close to Lyon. Is where we have our global R&D center and distribution center also for Europe. Then we have with us today Narayanan Mohan, who is the business development manager in North America, but a high educated and high experienced guy inside of the DC fuse topic, where he lead also several projects in the past, and he was also application engineer, so he knows exactly about what he's talking. And then we have also Tom Trong, which is also located in Saint-Bonnet, which is the business development manager for Switzerland and France. And he is also covering all the product and tries to manage the interface between the different production sites, MERSEN Switzerland, as well also to the engineering of the OEMs in Switzerland. This could be any applications, but really dedicated, mostly the biggest success we have inside of battery or semiconductor business. So next slide, please. As you mentioned, MERSEN is a global company. We are on the stock market in Paris, and we count to the top 120 companies in France. But nevertheless, beside of the sales, we reached first time over 1 billion turnover last year. I guess the most important thing to know is we have more than 7,000 people around the world. And for you, especially for the iBAT members, a point to mention, we have 18 R&D centers around the world, and we are working close with universities. If this is not sufficient, these 18 centers, we are working close with many universities also around the globe to really to develop and to bring forward our business and our products. As a global company, we are also present in many countries, roughly 34 by end of the last year. How are we organized? You can see we have two main branches. One is called Advanced Material, which covers roughly 50% of the sales. This is dedicated mostly to graphite. Graphite means also semiconductors, graphite, but also means power transfer, and it means also resistivity against acids and so on. So we are really dedicated in this world of graphite, half of our group. And the opposite side, the electrical power segment is also growing fast, and it is also reaching 50% quite soon, where we have really a unique product range of a small part we will present today, which is dedicated to battery and to energy storage, fuses, laminated bus bars, coolings, capacitors, name it what you want. It is really every product you can imagine around energy transfer, energy transmission in the capacitive way. A big bunch and a big dedication also of us is the CSR. Means we have really employees, safety, health, environment. It is not just, let's say, nice to have it on PowerPoint. It is really something we live around the globe, where we try to have zero CO2 plants in India, in other countries, but also we are really rated. EcoWatt is the third time now in 2023 gold level, close to the platinum level. So CSR is really in the strategy of MERSEN, and this is also something when we take energy, electrical transportation and so on into consideration. But nevertheless, I will not spend too much time on organization. You are keen to get more information about techniques and solutions. So Tom, please share again your screen. I lost your screen, Tom.
Yes, I was just unmuting myself. I hope it's good right now. Can you see my screen again?
Nope.
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 Okay, so sorry for that. I will share again. Okay. Should be okay right now. Sorry for that.
Yes.
Looks better now.
Yes. Okay. Thank you.
Thank you,
Stefan. Thank you, Stefan, for the introduction. As mentioned by him, we have half of the turnover made on electrical power branch. And inside this electrical power branch, we have a range of products that we called solutions for power management. So those products are used for power conversion and also battery application in several applications all around the world. So what are the different products? We have fast-acting DC fuses, you can see on the left, for different kind of protection, different kind of application and standards. Then we have the cooling solution with different technologies, air cooling, hybrid cooling with heat pipes, and also liquid cooling. And then we have the bus bars for different typology, I would say. We have bus bar for inverters, bus bar for batteries, and also bus bar for distribution. And last is the capacitors, where we have two types of capacitors, film capacitors and electrolytic capacitors. Based on the experience of all those products, we also provide co-development and engineered solutions to our partner to co-develop, for example, power stacks, but it could be the same for battery, where we will put all those passive components around the active components, like the power modules or the batteries, the battery cells. So this is linked to what I This slide is showing two value chains, one for converters, power converters, and one for battery pack. What can be seen is that our products will integrate inside those two value chains at almost the same level. We will protect the system with the fuses. We will interconnect the system thanks to the bus bars. We will cool the systems with the cooling plates, and we will filter the systems thanks to the capacitors. This for various applications, including, this is the topic of the day, the batteries inside the embedded batteries, but also energy storage or charging station. Regarding the implementation, the global implementation of our solution for power management products, we have a local-to-local approach, meaning on the three main regions we are working with customers, we are trying to have all of the products having a factory, but not only for production, also for all the R&D centers, like Stefan previously explained, and also all the logistic, which is managed site by site. So you can see that globally on each big region, we have the production of cooling busbar and fuses. And for the capacitors, at the moment, it is only in Germany. So now I suggest we go more in detail on the four products we presented. And I will let the floor to Damien, a Global Product Manager for busbars.
Hello everyone. Thank you, Tom. Next slide, perfect. A lot of products can be called busbar in our industry. And at MERSEN, this is what we produce as busbar. So if you look at the four pictures from the left to the right, you have laminated busbar. It's an assembly like a sandwich with conductors and insulation film. And they are mainly used in power electronics inside inverters and converters to interconnect power modules and capacitors. The main target here is to reduce the inductance to the minimum in the assembly. The second product you see here is the busbar we have to interconnect cells, so inside the battery modules. This is the topic of the day, and the range is well known at MERSEN with the name InfiniCell. The third product is powder-coated busbar. Here, the main application will be defense and aerospace markets. It's basically simple interconnections with epoxy insulation. The fourth product family, as you've seen, we are trying to integrate more and more products to provide solutions to a customer and not only components. So here's the assembly of capacitors on laminated busbar. The capacitors are soldered on the busbar by MERSEN and delivered pre-tested to the customer, so they were ready to use. The most request we've got at the moment on this is aeronautic. So just keep that in mind. MERSEN, it's 65 years of experience in busbar. We have engineering and R&D teams all around the world, so we can work with you really close. 5 factories in France, US, India, and China to produce the product really close to where you need it. We have a large panel of solutions and a strong investment in R&D to develop our offer year after year. And you will have technical support in every single factories, so really close to your engineering offices. Next slide, please. So here's the focus on our sales connection system. So we reuse the laminated technology we know for years to provide the same solution of assembly for this CCS solution. So we provide with this range flexibility due to the lamination and the insulation film, resistance to vibrations, and also space saving. As you will see that compared to a plastic casing, we have a really thin design. And this is covering most of the market, even the most demanding. So we are making the interconnection of cells inside the battery module, as well as the battery management system, which will guarantee a safe system. So we will provide only one product covering both needs, power, and signal. So monitoring part is really key on the products, as we see now. It's more and more important and big part of the cost of the products. So this is why we are dedicating our engineering to help you design the best solution, which will fit your request, but also reduce the cost as much as possible. And we are also working to develop new features, such as fuse tracks and to protect the BMS, or pressure sensors, for example. So the benefits of these products will be, of course, only one product to cover both signal and power. It will it will avoid wiring errors at your facility. It will reduce the voltage drop. It will increase the current carrying capability, and as mentioned at the beginning, a high resistance to vibration and shocks. Next slide, please. So we are developing today battery bus bar for all types of applications. The first we are thinking is electrical vehicles, of course, because this is where we have the biggest volumes. But we're also working in heavy duty vehicles, aeronautic, marine, could be defense or civilians, energy storage, and railway markets, for example, for tram applications. Our design is adapted for small volumes as well as large volumes. So, for example, here on the slide in the middle, you see on the top the Renault Zoe used for the Winter French rally race, the Trophée Andros. And for these markets, we are producing dozens of bus bar per year, more or less. On the bottom, you see the new E3008 from Peugeot, and for which we have been awarded not really by Peugeot directly, but by ACC. This is a public information, so it's part of Stellantis. And so now we will start supplying those bus bar for the M platform of all electrical vehicles size M of the Stellantis group. So now we are talking about millions of pieces. So with the same company, you can develop really small volumes or really large scale, and it will not be a problem for us. Our design is adapted also for every type of cells. So we can interconnect cylindrical cells, prismatic cells, pouch cells, and blade cells. So just keep in mind that no matter what is your application, no matter what the size is your need, or no matter what the cells you will use, we will have a solution with our design. Next slide, please. So this is our value proposition. So we call it the infinite cell design because it's you can duplicate the pattern we will design for you, let's say with a really large scale. So with you, we will help designing the right pattern to connect the cells, no matter what the size is and the size and the cell type you will use. And this will help you to connect on the same size of your battery module, plus and minus. So you will need only one bus bar to connect all the cells and also the monitoring. So you will reduce the quantities of components to manage. Also, the other size of the battery pack can be freely used for thermal management, for example, using a cooling plate to reduce the heat inside the battery pack. We have an ultra-thin design, so the bus bar will help you save cost and space because you will have a smaller modules. And even if you will have a thinner solution, we will limit the overheating. So for that, we have a team making all the thermal simulations of the bus bar. So this will help you to really design the product and use the thinner metal sheet as possible to reduce the cost. So we will also support you with this simulation. And also the pattern you see here can be easily compatible to high-speed lamination process. So this will help to reduce the cost, but also we will be able to supply a lot of bus bar per week or per month. Next slide, please. Here are two examples, cylindrical cells on the left and prismatic cells on the right, both using some plastic casing solution. So this option, has an impact on the thickness, of course, as I said. So you will design a bigger battery pack. You will have also less flexibility in the mounting, so you will lose time on the mounting, and it would be harder to do this in automatic way. The monitoring is managed most of the time separately, so it could be delivered on top of the plastic casing, but there is a risk that the two parts split, and then you will either damage the components, or even a risk to lose time in the mounting process. And also, the bigger the cells will be, the higher the thermal management challenge will be. So if you move to the InfiniCell solution, by the connection of both plus and minus soldered on the top, you can manage the thermal on the bottom. We can connect all type of cells, and thanks to our thermal simulation, we will design the best bus bar to avoid overheating. Can you go next slide, please? So here's a zoom. You can see on the left of the pattern to connect plus and minus on the same side. So you see here that we will multiply the pattern as long as you need in width and length. So even if there's a high density in the connection, we can manage the integration of the battery management connections through the FPC. So it will be connected inside the battery bus bar, so it will be completely transparent for you. And the bus bar will be tested for power, but also for signal before we deliver it to you. Next slide, please. So we made a design compatible with basically all the solution to connect the bus bar to the cells. So you can use wire bonding, you can use ribbon bonding, ultrasonic welding, laser welding. Basically, we will adapt the design, and we will help you design the right bus bar, depending on the equipment you have, of course. If you want to invest in a new equipment, we will advise you to go for laser welding, because it's basically the fastest. So we worked closely with a company named FNK Devoltech, located in Germany, and we designed a specific tool which will connect the plus and minus at the same time, and it will help you to really move really fast. I'm not going fastest.
No, it's automatic. Sorry, I don't know.
Okay, no problem. So basically, this solution will be 4 times faster than the wire bonding. Next slide, Tom. So monitoring, as I said, is a key part of our design. So we are working mainly with flexible printed circuits. Copper and polyimide is the solution we are developing today. So we will help you design the right FPC to match the bus bar, and integrate it to deliver it as a monoblock part. Of course, we can discuss about the connectors. We have a good partnership with connection manufacturer, so we can even give you the best solution on the market at the moment. So as you can see on the drawing, the FPC is installed in the middle of the bus bar. So this will help the system to be really strong, and avoid and provide a high resistance to stress, and also to vibration. And we will install the FPC inside and do the welding of the FPC directly on the bus bar, which will lower the electrical resistance. Thank you for the notes. Right on time, Tom.
Yes, I haven't clicked anywhere, so I don't know.
So last word on the bus bar. So just wanted to mention that We're investing a lot in R&D to develop our offer, and we also participate to funded projects such as Levis, for example. So here we are working with 13 partners around Europe, so it's funded by Europe. And here our target as MERSEN and busbar manufacturer for a battery module is to reduce the weight of the product, really important for vehicles, and even more important when we are talking about planes, for example. We also work to reduce the time of production, to speed up the production and reduce also the energy consumption in the production of the busbar. We also want to work on reducing the cost of the monitoring connection function. It's an important share today of our costs, so it's a big target for us. And we also work to provide safer solutions by looking for solutions to reduce thermal runaway problem. So last word on my side, if you also have on your side R&D development project, do not hesitate to reach us. We might be able to collaborate. We have a few PhDs guys, so 3 in France, for example, working on busbar products, so they will be able to support you. Thank you.
Thank you, Damien. Now we will move to the DC fuses and the challenges versus AC. So I will let Narayanan take the lead.
Hello, everyone. Thank you, Tom. Yep, in the coming slides, we'll talk more about the DC fuses. So when it comes to the DC protection in specific, there is a specific challenge about the absence of natural zero that makes the job for a fuse to really mitigate the fault much more difficult to quench the arc, to be specific. So when we compare an AC wave, what is being shown at the left and to the right hand side, you have the DC fault current. The absence of natural zero, it makes the rate of rise of current. If you see the di by dt, what you see at the right hand side is being shown. It's predominantly dependent on the inductance in the circuit. So depending on what kind of application we are talking about, it could be a capacitor bank, we talk about a battery application or a DC traction system. So inductance to the resistance ratio, what is present in the circuit, would be the key factor when we talk about the DC mitigation of fault. So that is why the MERSEN specializes in the DC protection, thereby providing safety for these systems. So when we talk about DC, the important factor to be considered is the time constant. So a time constant is nothing but the ratio between the inductance to the resistance in the circuit. So thereby the associated voltage and the range of prospective currents, what the fuse has to really open for, has to be really understood, and the right fuse has to be implemented in the circuit. So this is something a specific importance when it comes to DC. Also, the degree of difficulty, interrupting a DC circuit, it's a function of voltage, a current, and the circuit time constant. So we need to know all these parameters to really size the right fuse. And then the important factor is also about the minimum current, or the smallest current, what the fuse has to really open for. So that is another crucial factor that has to be considered when we venture into the choice of selecting a DC fuse. So this is about the importance of DC and what MERSEN can specialize in the DC fuses. Go to the next slide, please. Yep. Next slide, please. Yeah. Could you, Tom?
Yes.
Yeah, could you please? Yeah. Okay. So now coming to the electrical energy storage, in specific, we have a DC fuse lineup as shown in the single line diagram. You could see the different rack level fuses. You see the section level fuses and also the inverter DC fuses. So when we talk about each of these fuses, MERSEN has a wide range to provide these fuses for the system. When we talk about battery rack fuses, the blue ones, depending on which rack the fault an analysis can be done and the right fuse can be selected for those. And when we talk about the section level fuses, the one step above those rack fuses, so those section fuses shown in orange are the one which is bigger in size. So these fuses can be sized accordingly. And also when we go to the power conditioning system or the PCS, what is just above these section fuses column, so we can size these DC side inverter fuses depending on which location of these where these fuses are being employed in the given energy storage system. So here we talk about 1500 volt DC as a system voltage, and these are some of the DC fuses lineup to show you. Next slide, please. So this is something when we focus on the DC fuses at the module level, when we talk about a battery module level, in-bat fuses, the one what you see, which could be of 250 volt DC, and this can be custom made. And for short circuit protection, these fuses can be employed. And then when we talk about rack fuses or a section fuses, ABAT fuses or a high-speed DC fuse could be a choice. The one what you see at the left-hand side, which is a UL rated fuse, and the one at the square body ones, which are nothing but the IEC ones. So this is the clear distinguishing factor between these two type of fuses, and it could range up to 500 to up to 5,000 amps on a high-speed DC fuse. It's possible. And when we talk about the PCS or the battery container level fuses, we could have a ABAT and a GBAT fuse. So the ABAT, we talk about semiconductor. So we talk about a battery fuse which has a partial range of protection, which is employed for short circuit conditions, and GBAT is more pronounced for short circuit and overload conditions. So this is the key defining factor between ABAT and the GBAT fuse, and the right fuses has to be selected depending on the circuit topology. Next slide, please. So this is something the fuse lineup when we plot between a voltage and the current. What is the range of voltage and current MERSEN can really engineer and supply to you? It's on the ABAT rack fuses from 1000 volt DC to 1500 volt DC up to 500 amps. We do have a range to supply, and then we have ABAT section fuses, which is up 1500 volt DC, and then ABAT inverter and rack fuses, which could be of 1500 volt DC up to 500 amps, which is under development, and 1200 volt DC. We do have a range which is of a new size which MERSEN has introduced. So this is about the high performance DC fuses, shown as a voltage in the current range. What MERSEN can engineer and supply. Next one, please. So MERSEN fuses can be a part in the charging infrastructure, specifically when we talk about charging stations. At the left-hand side, what you see is a power supply cabinet. It could be a current limiting fuse of Class J, Class CC fuses, and also power distribution blocks. When we go into the DC fast charging, which is predominantly one of the major market where MERSEN is working with. So these inside this DC fast charging circuit, we could have different bus bars for the power conversion. If you have a DC link or you have some power conversion system, we could customize those bus bars and engineer them. And on the cooling to cool the power devices, we could have it could be SiC device or a SI device. We could have an air cooling or liquid cold plate made for that, and then overcurrent protection in specific to fuses what we saw. So these are the EV pack fuses, so which are specifically tested for EV conditions, having the required current cycling and specific certifications for the EV range. It's been tested, hence we call it as EV pack fuse here. And of course, capacitors for the DC link, or it could be at the filtering application. We have a wide range of film and as well as the electrolytic, and also we can make some capacitors which has a bank assembly depending on the microfarad requirements and the voltage requirements. Low voltage switch and SPDs are some of the other ranges for products what MERSEN can together as a bundle supply to this kind of charging platform. Over to the next slide, please. When we talk in specific to EV, the electrical vehicle and the HEV applications, MERSEN has a wide range of solution. We talk about battery module. At the module level, we have an in-bat fuse, which is a short circuit protection between the modules. These fuses can be introduced. We did saw the different range of these in-bat fuses in the earlier slides. I'm talking about the monitoring bus bar to monitor the cell level depending on the cell type, the architecture of the cell. This could be custom made, and the cold plate of thinner cold plates could be of 7 millimeter in size. This could also be done by MERSEN with vacuum brazing technology, and power inverters for the capacitors to form the DC link, or it could be for the power conversion bus bar, or you could have the cooling system. It is at the power inverter level. And when we talk about electrical protection of vehicles, those EV pack fuses, the in-bat fuses, and some auxiliary fuses that could go into the control systems for some specific DC ranges. MERSEN has into the junction box in specific. These fuses can be a part of what MERSEN can really evaluate and become a strategic supplier in those segments. Next one, please. So this will be the last slide about the testing capabilities or the high power testing power lag capabilities what MERSEN has. Up to 1500 volt DC, 350 kiloamps. This is something which is a remarkable testing power level what MERSEN has, both in France, in Saint-Bonnet, and also in Newburyport in Massachusetts in USA. So these two test labs can handle such a high power level of testing capabilities where these fuses can be tested. So thereby creating an authenticity of supply for our MERSEN fuses. And also important to mention about the DIB-DT testing capabilities of 5000 amps per millisecond. So this is something very unique, and then MERSEN has the capability to produce a complete in-house power testing capability for our fuses. And these are having a certification and approved by many renowned agencies when we talk about UL, CSA, PDE, ISO, and IEC, and much more as mentioned in the slide. So this shows our capability on fuses and the testing in the testing front as well. So over to Tom.
Okay, thank you, Naraynan. Now I would suggest we focus on the cooling solution in line with batteries. So we have different technologies for our cooling solutions. We have different material too. In terms of thermal performance, we are starting with air cooling. Then we have a diphasic cooling, meaning heat pipes being inside air cooler. And then we have the liquid cold plates. Once again, different materials are possible, but the most performant cold plates, liquid cold plates, are used thanks to our vacuum brazing technology. I will come back a bit in detail on that. So on the left, you have the vacuum brazing part related to liquid cooling. This vacuum brazing allows a high thermal performance in a monolithic piece after going into the oven. It guarantees a perfect water tightness. It withstands very high pressure, up to 70 bars, no risk of corrosion, and a very long lifetime, over 20 years and even more. So on the left, liquid cooling. In the middle, this is the technology we use for our air cooling. It's called the swaging and stacking. And this helps to have a custom-made solution on the fins. So in the height, the length, and so on, in order to increase the heat transfer surface and allows more complicated design at extruded air cooling solution. So it's really custom made in comparison with extrusion and allows more performance with more complex design. On the right side, we still have our air cooling technology, but you will notice that in the middle of it, we have heat pipes that will allow to spread the calories along the complete cooling. So it allows a better thermal performance in comparison with standard air cooling, a temperature homogeneity thanks to the heat pipe, instead cooling, it smoothens the temperature peaks, and it's maintenance-free. Few examples now about the different technologies. Here you have liquid cold plates in aluminum, vacuum brazed, as explained before, and designed for battery cooling. It has a 7 millimeter thickness, which is most of the time requested for the cooling of the batteries. And it has been custom made based on the technical specification from our customers to ensure a power thermal performance. Another example is a new, quite new product we are proposing. It's embedded heat pipe air cooling. So you will notice on the pictures that we have heat pipes that have been inserted on the base plate, and this allows homogeneous heat spreading across it, no hotspot. So it's a good compromise between liquid cooling and air cooling, meaning that it will bring more performance in comparison with air cooling, and in this case, and for certain application, a cost and weight effective solution. As for the air cooling, the benefit of no maintenance is also important. So this is what we can do. Once again, custom made, so meaning the heat pipes can have different shapes, the base plate too. The fins can be longer or longer. Everything is designed as per the specification. We also have a thermal simulation to have a view on how the heat will spread and to optimize the design. So for the application in railway, solar, wind, EV, UPS, motor drives, amplifiers, and so on, we are offering this product to our customers. Thank you for your attention. I hope you enjoyed this presentation. Thank you for your participation. If you have any question, it is now the time. If you have questions coming in the coming days, do not hesitate to contact us. We remain at your disposal. Thank you.
Yeah, thank you very much. I haven't seen yet the questions in the chat. You can also raise your hand, and then I think I can unmute the audience. Yeah, thank you very much. I think it was very, very interesting, the different possibilities we saw. What about when we talk about the bus bar? I think for manufacturing, it's a super interesting solution. It's a bit more because also this I liked very much that you basically can infinitely make it larger. What about the circular economy? Have you thought about possibilities on, let's say, dewelding or things like end of life handling for accessing batteries when we talk about, for example, direct recycling?
Can you hear me?
Yes.
Yes.
Yeah, okay. All the products we are manufacturing can be delaminated. So, for example, we have the solution. So as soon as you can remove the bus bar, you can divide the parts, even if it's not, I mean, really easy to do. To do the sorry, to reuse the metal or the other part, but to remove the battery, the bus bar from the battery cells, that's a good question. I need to double check. Because you see challenges around this.
Yeah. So the thing is, batteries become less modular, like right, with a cell to pack design and things like that. So the question is, at the moment, I would say we have mechanical kind of processes first to create what we call black mass, and after hydrometallurgy to have access to the important materials, especially the cathode materials of the battery and the lithium. But in the future, we try to develop method what we call direct recycling. So we would have access to, let's say, single cells in a more non-destructive way. So I think that could be something interesting that we could also have an exchange, maybe that could lead to some research questions that we could answer maybe from the Switzerland Innovation Park or from other partners from research in Switzerland. But as we are working in that field of disassembly, automated disassembly, these are, of course, questions that are coming up. Well, but again, a question to the audience. Are there questions? Now we have 4 experts from MERSEN, and I see that we have some battery pack manufacturer here in the call. I think it's a unique question. Of course, if it's more about things which need an NDA, you can ask the persons afterward, but are there questions to people from MERSEN?
It's again also from our side. So if you have any hints, any requests or any projects, as mentioned, we are open to sign NDAs. So we are used to work with OEMs and do co-developments. And as you can imagine, when we talk about designs of bus bars or cooling or even fuses, the sooner we get into the boat of the development, the better we can work together and the better the end solution will be. So we have faced several projects where more or less the whole cabinet is already designed, and then the question was, oh, now we need a fuse. Could you please provide us a fuse to handle this and these currents and stuff like this? But we are limited in size. And this is really something for all our products, bus bars, cooling and fuses and capacitors or stacks. Don't hesitate to contact us in an early stage. This is better for all of us, and we are used to do co-developments.
Well, there's still, I don't see any questions in the chat, so I will ask again. I have actually a lot of questions. I will not ask them all, but I saw that you have also two-phase cooling system in your portfolio. I think in the presentation we haven't seen too much about the two-phase cooling. Maybe you can say some words about that, Tom.
Yes. So the two-phase cooling is the combination of heat pipes that will spread the calories, and then it will go inside air cooling to then allow the thermal dissipation. So basically, it's enhanced air cooling thanks to the heat pipes going everywhere inside the air cooling to improve the thermal dissipation. So the two-phase means at the end what is inside the heat pipes. Depending on the temperature, the heat pipes, the calories inside the heat pipes, and there will be a phase change in the heat pipes that will allow to spread all the calories everywhere inside the heat pipes. So there is a change of phase, and that is why we call it diphasic solution.
Yeah, we also developed some pulsating heat pipes. So I think this is a bit of a development of the two-phase cooling. This is you use mostly for high power application, or also for batteries itself. You already use a two-phase cooling system.
For batteries, we will most of the time use liquid cooling, mainly because the available space is quite challenging. With the air cooling or the diphasic cooling, the space is it's taking more space. But yes, for the heat pipe and the diphasic cooling, we are using it for power modules cooling.
Yep. Okay. Well, I think this is it's an interesting tool. Yeah. So if there are no questions in the chat, I would say I stop here the recording.